just delete it. Then we have x minus a to the power of 2. That is w plus z minus w. That gives you z, so it's z squared. Then plus. If you carry on, we have x minus a to the power of 3 to the power of 3, 4, 5, 6, so on and so forth. Next step. We are taking those terms within the bracket out. Let's look at the first one. Expectation of the utility of wells. The wells, initial wells, there's no uncertainty about initial wells. That is given from the question, kind of endowment. So expectation of something for sure remains the utility of wells. Doesn't change. Look at second term. Expectation of z multiplied with first derivative u, first derivative of w. According to the condition, given condition, expectation of the gamble should be 0, right? Because it's an actuarially neutral gamble. So expectation of the gamble of z should be 0. 0 multiplied with the first derivative of w. This term becomes 0, so it's gone. Let's look at the third one. Expectation of this part. 0.5 remain 0.5. Second derivative of u, w, second derivative of w is endowment. There's no uncertainty. Initial wells, so remains this part. What you need to pay attention is the z. What is z to the power of 2? Well, let me show you. Now let's have a look at the variance of the gamble. By definition, here it is. Variance of the gamble equals expectation of the particular outcome minus the expected value of the gamble. Right? And again, according to condition, given condition, expected value of the gamble should be what? 0, right? So this term is gone. So the variance equals expectation of that square. Right? But here we have expectation of that square. Right? So we can rewrite that as a variance to the power of the variance, which is the standard deviation to the power of 2. Then plus a lot more other factors in which that is included, and it's to the power of 2 to the power from the power of 3 to the power of n, which again is tend to be very small. So we tend to ignore them. Like what we treat the pi square on the previous page. Just recall what we get from the previous page, which is utility of wells minus pi multiplied with first derivative of w. It equals utility of wells plus half multiplied with variance multiplied with u to the power of 2 and w. Here it is. You can just rearrange this. I believe you can do this. Just algebra. Then you can get pi. It equals half multiplied with variance multiplied with the ratio of negative second derivative to the first derivative. This is how you solve the product error measure. For the relative risk premium, or AA, which is the thing in the bracket. Why? As I told you, for risk aversion, averter, the risk premium should be positive, right? And half and variance, they're square here, they are always positive. So whether the pi is positive, negative, or 0 is purely depend on the ratio. If you know the sign of the ratio, then you know the pi, whether it's positive or negative. So the relative risk aversion, RA, right? Relative risk aversion is the ratio. By knowing this, you know whether the agent has risk aversion, risk loving, or risk neutrality. Well, I hope it helps. And for some other derivations, as they are just kind of simple calculus, I believe you can do them by yourself.